If you know all of the math from the SAT but still can't score an 800 because you keep running out of time, this video is for you. I'm going to share a whole bunch of hacks with you, show you how to use them, and give you free access to a bunch of practice questions so that you can apply what you just learned. Let's get started with Desmos hacks. And your first hack is the word table. So on a question like this, where we have a table, type the word table and a table will appear. Now put in your points. Now, importantly, if we're dealing with something quadratic, we're going to need at least 3 points. So we're going to need to put all 3 of these guys. Now, push this little button right here. It's going to add a regression, which is basically, it makes a graph and it also gives us an equation. Now, currently it's set for linear. We know this is quadratic. So we're going to want to pull this down and click on quadratic. Now we have an equation. And what is the question asking us again? It's asking, what is the y-coordinate of the y-intercept of f of x? Now, importantly, this is not f of x. This says we're looking at f of x plus 9. So our y-intercept for this is negative 2,292, but that is if we add 9. So in order to reverse that, we're going to subtract 9. And if you're scared of making a mistake, you'd always just type your number here, minus 9, and get your answer, negative 2,301, which is indeed our answer. Linear equations are even easier because we only need 2 points. This one only gave us 2 points, but if they had given us, 7 points, we would only have to type 2 of them. So again, we're just going to write the word table. We're going to put on our points. We're going to click the button. And this time, since it automatically goes to linear, we are in the clear. Now, importantly, the question is asking us, what's up with k if we have this point 3 over 8k? So a couple different ways you could go about this. You could say x equals 3 over 8, and then you could find your point of intersection, and your y value is k, so that's going to be your answer. So we know it's 28.5. You could also throw this equation into the line and actually just fill in the blanks. So if we were to do that, we would have k, which was y. Squiggly, you're going to learn about this in just a second. Negative 4 instead of x, we're going to have what they gave us, which was 3 over 8 plus 30. And it's going to give us 28.5 just right here. But Robert, what about exponentials? Yeah, we can do exponentials. Let's do it. So same thing. Write the word table. Put in your stuff. Little bonus tip for you. Do not use commas. Desmos hates commas. Not a huge fan of punctuation. All right, again, click it. We're dealing with exponential. We're going to click exponential. Now, importantly, we're not going to get an exact match when we're dealing with exponential regression, but if we look at our answer choices, choice C is clearly our answer because it's the only one that starts with 1200 like it should, right? And then if we were to evaluate this 1 plus, 0.015, basically I have 1.148, which would round up to 1.015. So perfect match right there. All right, next up, we've got something that one of my wonderful private tutoring students has dubbed the Squiggly method. The reason being is we're going to use a squiggly, which I kind of showed you earlier, but let's take a look. So with this, we could obviously put everything in. And then from here, we're going to have to find our vertical line, which would equal x. So we know x is negative 22.2. And then it's asking about 7x. So we could do negative 22.2 times 7, get our answer, which is negative 155.4. Cool. But we could also use the squiggly method and not have to look at the graph at all. For the squiggly method, we're going to change our x's to some constant. I usually just go with a for x. Whatever you choose, stick with it. And then importantly, we're going to need to change our equal sign to a squiggly, also known as a tilde. It's going to be that little mark right next to the 1 on your keyboard. Boom. And now we get our answer for a. And what's even cooler is, instead of having to do this, we could literally just type 7a and we get our answer. And that, my friends, is the squiggly method. Now, of course, there is an advanced version of the squiggly method. If you're dealing with infinite many solutions, meaning x actually equals every possible value of x, and you have constants in the mix, you're going to want to do something a little bit more advanced with the squiggly method. So you're still going to start off by typing everything from the equation. So we've got everything in place. We used our squiggly, but what gives? Well, last time you remember we changed x to a, right? Now, if we do that here, it is going to give us some stuff. And unfortunately, this stuff is not true. Again, it's because we're dealing with infinite many solutions, and this says a equals 1, but x should not just equal 1. X needs to equal all the things. So instead, what we have to do is say that a equals random, and then we're going to put some number. 5 usually cuts it, but you could do 5, you could do 50, you could do 599. And you can see we're going to get some different values for C and D, and these are the real values for C and D. So this is how we would know that our answer for this one is 450. And you might be wondering, what the heck is this, man? So basically, since I said A needs to equal all the things, that is to say, X is supposed to equal all the different values of X, the command random is going to choose some random values, and then this number is going to be the number of values. So if I say random 1, it's only going to give us 1 random value for A. If I say random 2, it'll give us 2 random values for A. And I usually just go with 5 because, I don't know, I like the number 5, but choose your own number. And then because we already have constants here, if you're scared that you're going to mix stuff up, you could change your A's to X sub 1s so you don't lose track of your X's. Then you just want to make sure that your X sub 1 is equal to that random 5. And again, it'll give us our answer, which is 450. Hack number 3 is evaluating functions. And when I talk about evaluating functions, I mean stuff like this, where we're supposed to figure out different values of different inputs and outputs of functions. So for these guys, we are gonna type exactly what was given to us straight into Desmos. And then we are going to evaluate our function by typing the other thing. It's asking about the product of H12K and H9K. So it would be those two things multiplied, right? And right now it doesn't like us because we don't know what the heck K is. What does it tell us K is? For this one, it says K is less than 0. So I can literally choose any value less than 0. So I'm just going to say that K equals -3. When you are choosing your own values, be careful. We don't want to choose 1 and we don't want to choose 0 because sometimes you will run into problems. Otherwise, as long as you're following the instructions, in this case, the instructions are make it less than 0, you are going to be good to go. So yep, our answer for that one is going to be 1,258. And finally, hack number 4 is going to be using brackets in Desmos for systems of equations. This first example is one that I wouldn't recommend using brackets for, but I want to use it to demonstrate the process. So we have a system of equations, and basically we're going to use brackets to separate our system of equations. And the way this works is you have a bracket, and the first set of brackets is going to be the left side of both equations, and then you're going to have that squiggly to the right side of both equations, separated by commas. So since our first equation, the left side is 2y, we would say 2y, or in this case, I'm going to say b for y. And then the left side of our second equation is y plus 4, so I'll say b plus 4. On the right side, since the first equation is equal to 5x, I'm going to say 5x, but in this case, I'm changing x to a, comma, 3x, so 3a. And as you can see, it is now giving us the value of both x and y. We just have to remember that we set x as a and y as b. So we're looking for the point 820, which is choice B. And again, that is probably not the most effective way of solving this one. But this strategy is going to be really useful on something like this. Let me show you what I mean. So we've got our brackets ready to go here. And what we're going to do is add the information that they're giving us. P is means P equals. So the left side of our first equation is simply going to be P. And then is, on our right side, 145% greater than Q. To add 145%, we would multiply by 2.45. That's because we have 145% that we're adding plus an additional 100%, which is our additional 1. So we get 2.45. 2.45, the number Q. And then our second equation says the number Q is, so Q on our left side is 30% less than 60. 30% less would be 0.7 because if we subtract 30%, we're left with 70%, right? And then we just stick the number 60 in there. And as you can see, we have our values. It's asking us about the value of P 102.9, which is indeed one of our answers, choice D here. And like I mentioned, I've got a ton of practice questions for you so you can practice what you're learning in this video. Just use the link in the description. To not do so would be a bad choice. Up next, we've got algebra hacks. Starting with number 1, the fraction swap. And the fraction swap is simply if you have a whole number, for example, 2, equal to a fraction, which we could say this is equal to 2 over 1, the rule is you are allowed to switch the whole number with the denominator of the fraction that it is equal to. So if we did that swap, we would end up with 1 equals 2 over 2, which of course is true. So you can see that it does indeed work. Looking at this question, it makes it quite easy because our first move is swap. We have 13 plus r equals 19 over q. And now to get r by itself, we just subtract that 13 and we are all done, which means our answer is choice A here. Next up, we've got coefficient matching. And this is going to work with linear equations with either infinite solutions or no solutions. And the rule is if you have a linear equation in one variable, regardless of whether it's no solution or infinite solutions, you're still going to have the same slope, meaning your coefficient for x is going to have to match. So I can basically ignore this and just focus on 5kx equals negative 35 over 6x. After that, it gets even easier because I can divide by x to get rid of x. And now I can just say that 5k is equal to negative 35 over 6. After dividing both sides by 5, I get k equals negative 7 over 6. So we've got x coordinate of the vertex. So here it's asking us for the value of x when y reaches its maximum. Just in case you didn't know, that means the vertex. The minimum or maximum of a parabola will be the vertex. And maybe we're thinking,
but that's easy.
Easy, we'll just plug it into Desmos and find the vertex, which should be simple enough. Cool, so gonna have to back off until we can see it, but there it is. And we're looking for the vertex, so it's gonna be up here somewhere. What is happening? What is happening? What is happening? So not only are we gonna have to scroll quite a bit to get to what we're looking for, but oh my goodness. Once we get there, there's another problem that we end up running into. Take a look here. This point that's marked 0, 1.8 times 10 to the 7th is going to be our y-intercept. And if you touch this first, you might accidentally think that our answer is 0, but in fact, our answer is negative 1, right? So to avoid all this craziness, we could just use negative b over 2a, negative b over 2a. And of course, I'm referring to ax squared plus bx plus c, meaning that a in this case equals negative 1200 and b in this case equals negative 2400. So obviously that's going to be negative 1. So our answer for this one is actually going to be choice B. And speaking of negative b over 2a, you're also going to want to memorize negative b over a, which is the sum of solutions. If we look at this, you might have nightmares later on because what the heck is going on? But then if you look at this and you know that negative b over a is our sum of solutions, it becomes a lot easier. Because again, b is the stuff in front of x. In this case, kind of annoying, but since it's all negative, we're just going to turn it to all positive. So 15p plus 21q over a, not 2a. This case, a is 120. And it says that all this stuff is equal to k 5p plus 7q. We want to get these sides to look like each other. So if we can make 5p plus 7q show up on the left side, we will be good. And we can certainly do that. We can take 3 out of here and factor this so that we get, instead of 15p, we get 5p. And then instead of 21q, we get 7q, right? Because 3 times 5 is 15. 3 times 7 is 21. Boom, we've done it. So now we just have to simplify. 3 over 120 is going to simplify to 1 over 40. And that would be equal to k using our matching, right? Because now all of this stuff we can basically just treat like a coefficient. So k equals 1 over 40. And along with the sum of solutions, you should also know the product of solutions. Once again, we've got something that looks kind of scary, but if we know the product of solutions is simply C over A, now we know that that is mn, because remember, ax squared plus bx plus c over 91. And according to this, that is going to be equal to kmn. Divide both sides by mn. Anything divided by itself is 1. K times 1 is 1. Mn over mn is 1. So 1 over 91 equals k. So our answer is 1 over 91. My next hack for you guys is to choose your own numbers. There are certain questions on the SAT that will give you some sort of a parameter that you can follow. For example, C is greater than 60. So here we've got this thing. There are other ways we can go about it, but I want to use Desmos because I'm lazy, right? So I jump into Desmos and then I'm like, all right, the issue is I don't know what C is, and I could take C and I could say that it equals something, but it's asking me what is true. So like, what the heck do I do here? Well, we follow the rules. C is greater than 60. So let's say that C equals 61. Now let's check out our situation here and figure out what is indeed true. So if we look at our solutions, we've got 58, we've got 60. So which of the following are solutions? Well, C itself is 61, and that's not one of our solutions. 58 is one of our solutions, so 2 is true, and 60 is indeed 61 minus 1. So 2 and 3 are both true, so it's choice C. And then you're like, what the heck, man? What if you chose a different number? Well, let's see. As long as it's greater than 60, let's try, I don't know, 96. Now we have the solution 58 once again, and then 96 minus 1 is 95. That is indeed a solution here. So you can see that it's going to hold true no matter what we choose for C. Next up, we've got the discriminant, and this is something that you might remember from the quadratic formula. So the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. This thing, ugly, sometimes useful, but what's really useful in certain situations is the discriminant, basically all this stuff under the radical sign here. And the reason this is useful is because it's going to tell us the number of solutions for any given quadratic. Basically, if the discriminant is, we'll just say d for discriminant. So if d for discriminant is greater than 0, that means you have 2 solutions. If the discriminant is equal to 0, that means you have exactly 1 solution. And if the discriminant is less than 0, that means you don't have any solutions. Sad face. Here it says we have exactly 1 distinct real solution. And again, you might be thinking there's no need for this because we can just use Desmos, right? So if we put our equations into Desmos, we add our slider for k, we just have to slide it around until we have 1 solution, right? So we're like, all right, we're going to slide it, we're going to slide it. That looks like 1 solution. So we zoom in there, trying to figure out what is that. But oh, are you seeing what I'm seeing? It looks like we've got 2 solutions here, right? Okay, so maybe it's 0.5. Wait, now there's no solutions? And now you can see that we're going to end up with some stupid decimal. So the slidey trick is not necessarily the best choice here. So instead, we can use the discriminant, which remember is going to be b squared minus 4ac. And for 1 solution, we want that to be equal to 0 or squiggly to 0. Now we just have to fill in the blanks. Of course, they did not give us a perfect quadratic here, so we're going to have to use a little bit of know-how. Basically, we're going to combine these equations together. So if I go ahead and just subtract this equation from the top equation, which I'm allowed to do, we're going to end up with no y's. And that's one of the reasons I'm doing it. We get rid of y to simplify things for ourselves. Basically, we want to set everything equal to 0. So this will make y equal 0. And then k minus negative k is the same as k plus k. So we get 2k. And I'll just put this straight into Desmos. We subtract x squared from nothing. So we get negative x squared. 2x minus 3x is negative x, and then 4 minus 5 is negative 1. Then, of course, we don't want this 2k on the left side, so we're going to subtract the 2k at the end there, and then this will all be equal to 0, which is what we wanted, right? So we can treat that as our actual quadratic, and now we're just using this as a reference to fill in our blanks. So in this case, b is negative 1, a is also negative 1, and c is negative 1 minus 2k. And now it's giving us an actual value for k. Boom, we've got that. Yeah, so k is going to be -3/8 for this one. Next up, we've got starting point and rate of change. And basically, if you're dealing with a y equals mx plus b type situation, you need to know that m is a rate of change and b is a starting point. When you know this, questions like this one become super easy because we can see we have y equals mx plus b, or in this case, h equals 9n plus 6, but it's the same situation, right? So 9 is our stand-in for m, so 9 needs to be some sort of a rate of change. So choice A is out, choice B is out. Now we have two rates of change, right? Increase in levels for each foot, or increase in height for each level. Now it becomes slightly more complicated, but we just want to keep in mind that m, our slope, is going to be rise over run. So whatever y represents divided by whatever x represents. Here, y is h, and it says h is feet, so it's going to be total height in feet for every one level x increase. So choice D is our answer. And for other linear word problems in standard form, it's important to know the items and values rule, which is when we have ax plus by equals c, a and b are values, x and y are items, and c is our total. So on a question like this one, how many more pounds does this weigh than this? Pounds would be a value, it's a weight, that's being attached to the items. In this case, the items are parcels. So 12 and 28 are the 2 pounds, the two values. How many more pounds does the heavy duty one weigh? Well, we have 28 versus 12. So it's really just 28 minus 12, which is 16. So our answer very easily, if we know this rule, is going to be 16. And our final hack here is the zero-intercept rule. Basically, you just have to remember that at the y-intercept, x equals 0, and at the x-intercept, y equals 0. So it's asking for the x-intercept of this line, y equals 0, meaning y disappears. 1 times the reciprocal of 4/5 is 5/4. So x equals 5/4, and we've got our answer pretty quickly. This is why in standard form being ax plus by equals c, we can get our x-intercept using c over a, so in this case 1/4/5, which is what we did, or c over b for the y-intercept. So there's a couple of bonus hacks for you if you come across a standard form linear equation like this. Of course, it really comes in handy on something like this, where you might say, oh, this is linear, so b here is our y-intercept. Or, oh, this is actually exponential, meaning that this first number in front of the parentheses is our y-intercept. But in fact, that's not what's going on here. So instead, we just say x equals 0. That means 3 to the 0 is 1. Negative 15 times 1 is negative 15. Negative 15 plus 48 is 33. And our real answer is choice C here. Next up, geometry hacks. And up first, we have the -half circle hack. Say that 5 times fast. And basically, if you see a circle equation and it's not in the form that you're used to, but instead it's in this weird expanded form, you can take the -half of your coefficients for x and y to get your center. So straight up, we're going to have -10. So that's 20 divided by -2 and -8. 16 divided by -2. And our answer, just like that, is choice B. And this basically comes from trying to convert this into the proper form. We would need to complete the square. And when we complete the square, we end up going through a whole bunch of steps that you don't need to go through. But in case you're wondering, that's where this shortcut comes from. I'm not going to go into detail to that right now because I'm just trying to give you guys hacks. Next up, we've got the similar triangle copy. And basically, you should know that similar triangles have the same angles. So you are allowed to obviously copy their angles, but also you're allowed to copy their sine, tangent, and cosine. Because if you think about it, let's just pretend that we have a beautiful 3, 4, 5 triangle, another beautiful 3, 4, 5 triangle, and we have like 3, 4, 5, and 6, 8, 10. Let's pretend that we're looking at the sine of this. So sine would be opposite over hypotenuse. So we would have 4/5. If we took the sine of this similar triangle, it would be 8 over 10, which once we simplify becomes 4 over 5. So basically, no matter what happens with scaling, no matter how much bigger or smaller one of the other triangles is, the ratio is the same, and the fraction, once simplified, is going to be the same. So in actuality, we're looking at this triangle that has lengths of 20, 21, and little bonus hack for you, 20, 21, 29 is another Pythagorean triple, but obviously you could just use the Pythagorean theorem to get this 29. And it's asking you tan of A is 21 over 20. So that would mean A is like here, and we have opposite over adjacent. That's TOA, SOHCAHTOA. And then it's asking about sine of D. Well, D does line up with A. So this would be the same angle, but for sine, it's SOH, opposite over hypotenuse. So opposite here is still 21. Our hypotenuse is 29. So our answer is 21 over 29. And this one obviously only works if you're familiar with using SOHCAHTOA. So if you don't know that, go learn that first. All right, next up, we've got the side scaling hack. And basically, if you're given the side of any sort of polygon, so let's just go with a rectangle, and we say that this is X and there's a similar rectangle that is larger, and we're going to say that this is 3X. So basically it's saying a given side of this rectangle is 3 times bigger than this other rectangle. And if you're dealing with perimeter, you can take that same scale factor of 3 and apply it. So if I said that the perimeter of the small one here is 10, then the perimeter of this bigger one would just automatically be 30. Very cool and makes sense, right? But the side scaling hack is if you are given area, you are no longer going with that 3 as your scale factor. In order to scale area based off of a side, you need to square your scale factor. So instead, we would multiply 10 times 3 squared, or 9. So our area for this bigger one would be 90. And in case you're wondering, yeah, this goes with 3D shapes as well. If we turn these into rectangular prisms and we were looking at volume, now all of a sudden we wouldn't want to square it, but we would want to cube it. So if our volume here was 10, then our scale factor would be 3 to the 3rd power, which is 27. So our volume for this one would be 270. Anyway, with all that in mind, let's look at this question. And if you want to pause and try it using what I just taught you, go ahead. But here we go. So basically it's telling us that ABC is 4 times bigger than DEF. It is also telling us that ABC is 270. So basically our scale factor is going to be 270 for area. We divide by 4, but since 4 is the side length, it's 4 squared. So yeah, 270 over 4 squared. If we simplify that, it becomes 135 over 8 as our simplified answer. Next up, we've got the equilateral triangle cut. If they tell you you're dealing with an equilateral triangle, you're probably going to want to cut it in half like so, because when you do this, you create a 30, 60, 90 triangle, which, as you should know, is a special right triangle. And this is on the reference sheet, so you don't have to memorize it. But basically with a 30, 60, 90, your shortest side is going to be X, your hypotenuse is going to be 2X, and your other leg is going to be X times the square root of 3. So following this logic, go ahead and pause the video and try this question on your own first. But here we go. So basically, if the perimeter is 20, we know that all of these sides are going to be 20 divided by 5, or 4. Since this is our 2x, that means that this shorter side is going to be 2, and the other leg is going to be 2 times the square root of 3. It's asking about area of the shaded regions. So basically, I just need to take the area of this and multiply it by 4. So I could say 4 times BH divided by 2, B being base, H being height. Base and height here are 2, and 2 times the square root of 3. All of this divided by 2. There's a lot of ways I can cut this, but I'll do it this way. We'll say these 2's cancel out. And now I have 4 times 2 times the square root of 3, or 8 times the square root of 3. So just like that, our answer is going to be choice C. Now, some of you might be thinking, what the heck? There's also this cool little formula for area of an equilateral triangle. So yeah, you could totally use this as well. Basically, it's going to be one of your sides squared times the square root of 3 over 4. So if I were to put this into Desmos, for example, if you remember, all of our sides were 4. So we would have 4, multiply that by the square root of 3 divided by 4. You're also going to remember that there were 2 of these shaded triangles in our little figure, right? So that would get multiplied by 2, and then you would have to compare to your answer choices. So then when we put 8 times the square root of 3, it doesn't match up because I am a noob. Oh, I forgot the squared. That's why. So it does match up. So you could also memorize that if you'd like, but I just like to think of it as cutting it in half and then applying these easy peasy 30, 60, 90 rules. Next up, we've got the sine cosine swap. And basically, it's already telling us this, but in any given right triangle, the sine of one acute angle is going to be equal to the cosine of the other. So if we have the sine opposite over hypotenuse, if you think about it, the cosine of this other angle is going to be adjacent over hypotenuse. So you end up with the same thing. So if this is A and this is B, they both end up being A over B. Again, this one you really need to know SOHCAHTOA to kind of understand what's going on. But this is a rule. This is something you should certainly have memorized. So basically when it tells us here that cosine of Q is equal to R, it's saying these guys could live in a right triangle together. And if we think about it, it also means that these guys have to add up to 90 degrees because we've got our 90-degree angle here. So then these other 2, by default, have to also add up to 90 degrees because there's only 180 degrees in a triangle, right? So when it tells us that the degrees are this and this, all we have to do is set this up as an algebra equation, knowing that they add up to 90. So we can pull Desmos up. We'll change x to a so that we can use our squiggly. A plus 61 plus 4a plus 4 is going to be equal, or squiggly, to 90. And just like that, it'll give us the value of a, which we subbed in for x, so our answer is 5. Along with that relationship, you should also probably memorize the tangent flip rule, which is that the tangent of an acute angle is going to be the reciprocal of the tangent of the other acute angle. And again, we can play the same game here. We'll just say we have, like, I don't know, A, B, C. And if we take the tangent, that is opposite over adjacent. So this is A over B. And then the tangent of the other acute angle opposite over adjacent is going to be the reciprocal, which is B over A. So memorize this. Just know that you have this reciprocal rule, aka flipping the fraction upside down. So if the tangent of one acute angle is this, the reciprocal is going to be 3 over the square root of 3, or choice D here. So our answer is choice D. And then finally, you've kind of already been seeing me do this, but basically just the Desmos geometry hack. Don't forget that you can still use Desmos for geometry. Basically, you just want to take the information you have, plug it into Desmos using any equation that you either have memorized or have from the cheat sheet. So when it tells us that we're dealing with an isosceles right triangle, we should know right off the bat that an isosceles right triangle is our 45, 45, 90 triangle, right? And the relationship there is going to be x, x, and x times the square root of 2. It's also telling us the perimeter of this triangle. And we know that the perimeter is side plus side plus side, right? And in this case, of course, the relationship would tell us that the perimeter is x plus x times the square root of 2. So if we throw this into Desmos, we'll change x to a again. So a plus a times the square root of 2. This is supposed to be equal to, according to this, 18 plus 18 root 2. So 18 plus 18 square root of 2. So now it's giving us a value for a, which is cool. but it's asking us about the hypotenuse of the triangle. So remember, the hypotenuse in this case is going to be a root 2. So in another line, we just write a square root of 2 gives us our answer, which is 18. So our answer here is actually choice C. And I guess a little bonus hack for you. Don't forget to use your reference sheet if you forgot the rule of a 45, 45, 90 triangle, or you forgot the rule of area of a triangle or anything like that. There's a ton of free formulas just waiting for you. So don't forget about that. And lastly, don't forget about these guys, problem solving hacks. First up, we've got percentage shortcuts. The first being how to add percentages. And basically to add percentages, you're going to do 1 point whatever, or the better way to think about it is take whatever percentage and add 1 to it after you convert it into decimal form. The logic being that the 1 is going to be your original 100%, and then the percentage that you add on is going to be the additional percentage. Importantly, on this question, we're being asked to add 110%. So we have to think 1 plus 1.1 for our 110%. So in truth, it's going to be 2.1. And once we know that, this is a pretty darn easy question, especially if we just plug it right into Desmos. So let's do that. And I like to use the bracket system of equations method here. W is squiggly 2.1, that's 110% greater. And then our next equation is Z is 55% less than 50, which brings us on to subtracting percentages. And to do this, basically you take whatever you're going to subtract it from 100 and convert it into decimal form. So if we wanted to subtract 35%, we would multiply it by 0.65, since 1 minus 0.35 is 0.65. So for this one, 55% less would be 0.45, since 1 minus 0.55 is 0.45. So back to Desmos, we have Z is 0.45 times 50. So again, that's 55% less than 50. And then our answer for W is 47.25. And then finally, when you're being asked about percent change, so basically this is talking about a percent increase, you want to use the percent change formula, which is basically the difference between your original and new value divided by your original value. Just keep in mind that this is going to give you a decimal, so technically you would also multiply by 100 in order to get it back to an actual percent. Anyway, following this, it says that the manager estimated that the percent increase from 2012 to 2013, so the one that we're seeing here, would be double the increase from 2013 to 2014. So whatever happens after that. So first, let's figure out our percent increase between 2012 and 2013. And again, remember that's going to be your difference divided by your original. So the difference would be the bigger number minus the smaller number. So 5880 minus 5600. And that's going to be divided by the original, which was the 5600. That's where we started. So 0.05 means we had a 5% increase. So 5% increase. And the manager estimated that this 5% increase would be double the increase of 2013 to 2014. So we want to cut that in half, since it would be double what we're looking for. And we want to take our number 5880 and we're going to increase by, that's right, 2.5% or 1.025. Going back to how we add percentages, right? So our answer there is going to be 6027, which is choice B here. Next up, we've got the median trick. And some of you are thinking, what the heck, dude, median trick? We don't need no trick. We could just put median into Desmos, put a list of numbers separated by commas, and it's going to give us the median, right? Okay. You could also easily find it in a short list by just finding the middle number after rearranging them. But what happens when you have a larger list like this one with 19 neighborhoods? This is where the median trick comes in handy. And it goes a little something like this. You take your total number of values and divide by 2. So in this case, it would be 19 divided by 2. That's obviously going to be 9.5. And when you get a decimal like this, because you have an uneven number, you're going to round up to 10. Now, importantly, 10 is not your median. Instead, the 10th value is your median. So now you just have to count up and find where the 10th value lives. So here we have 3 values. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th value is going to live here where we have 13 to 17 chads, meaning our answer has to be 15 since it falls within that range. And in case you're wondering, if you had an even number, so let's say we had like 20 neighborhoods in this town, and we'll just add like a third neighborhood here, then you would do 20 divided by 2, which is 10. And instead of rounding up, because we're already at a whole number, we're going to include the 11th and get the average of those two values. So in this case, we know that our 10th value was here. Our 11th value is also here. So either way, we would end up with 13 to 17 because basically 13 to 17, the average of that would still be 13 to 17 since it's two of the same value. So there is your median trick. Next up, one of my favorites is the Little Timmy trick. Give it up for Little Timmy, ladies and gentlemen. There he is. Yeah, he's kind of a sad guy, but he's very useful because he is meek. He is not confident. He is not sure of himself. And while usually this is not a good thing in life when you're trying to get ahead, it's a good thing when you're answering this type of statistics question where they're asking about some sort of an interpretation of a study. So basically, they're telling us what's a correct statement based on the given margin of error. So behaving like little Timmy, we're going to completely ignore the passage and the chart here, and we're just going to eliminate any confident answers, answers that give definitive statements. So the word approximately is nice because it's sort of hedging, not being too sure of oneself. But choice B, it is not possible. That is way too confident. Little Timmy would never say that, so we're going to get rid of it. Choice C, the percent of all US adults is exactly. That is a definitive, absolute statement. Little Timmy would never be so confident to say that. And then choice D, it is doubtful. Timmy would say that. Okay, now we just have to figure out what our actual question is. So it's asking about given margin of error. And as you guys ought to know, a margin of error is basically going to be a range that goes below and above the results of the study. So in this case, since our result was 42 and our margin of error is 4, we would go 4 below 42, so that'd be 38, all the way up to 4 above 42, which would be 46. So if we look at choice A, it says approximately 4% are misclassified. That actually has nothing to do with margin of error. So a little bonus tip for you, make sure you actually know what margin of error is. And then choice D, it is doubtful that the percent is 32%. Since our margin of error's lowest percent would be 38, it is doubtful that it would be all the way down to 32. So that is our answer, choice D. My next hack is the given that hack. And this is simply the fact that given that is going to apply not just to your numerator, but to your denominator. And I'm pointing this out because I've had a ton of high scoring students miss questions because of this, and I don't want you to do the same. So if we didn't know this, what happens to a lot of my students is we're trying to select something at random, and it's saying, what's the probability of selecting a flower from site A? So we'd be kind of honing in here, given that the flower is a tulip, and then we'd be honing in here. And we'd say, cool, that's 35 is what we're looking for out of our possible, and it did say we're selecting at random, so that would be the whole thing, and it'd be 35 out of 102. We would simplify that, and we would be wrong. Wrong, 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 wrong. Instead, we need to make sure that we understand given that applies to our population as well. We're honing in on site A as the actual desired outcome, but then given that is going to restrict our population. So in truth, our intersection here is going to be our numerator just like before, but our total is only out of 50. So we're going to simplify that fraction. I believe that's going to be 7 out of 10 or 0.7. So our answer is going to be either 7 out of 10 or 0.7. And then finally, I've got unit conversion squared. And this is going to be another type of question that tricks some of my high scoring students into missing out on basically free points. So you've got something like this where you know you have to convert square yards to square miles, and they give you the conversion, and you're like, oh, that's so sweet of you. As long as I don't screw up my numerator and my denominator, I should be good here. And speaking of which, I do like to use stoichiometry. So basically you turn your stuff into a fraction. So I would have my square yards on top here that I'm starting with. And this is just, over 1. And importantly, we want to keep our unit here. So yards squared. And then we're multiplying by our conversion rate, yeah? And the reason I like to set it up like this is I know that I want to get rid of yards, so I know that my yard should be in the denominator. That way, when I eliminate the numerator and the denominator, because we can do that if we're multiplying fractions and we see this same unit in the numerator and the denominator, so then my 1760 would be down here, and then my 1 mile would be up here. So basically, after we eliminated the yards squared, we would be left only with miles. And this is the mistake that a lot of students make, because if we throw this into Desmos, I'm gonna get this answer here, which lines up perfectly with choice D, and I'm gonna circle choice D, and again, I'm gonna be wrong.
Wrong, 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 wrong.
The conversion rate they gave us is not miles squared to yards squared, it's just miles to yards. And if we look at my little stoichiometry setup, this should also be a red flag, because in order to eliminate the numerator and the denominator here, I need the same thing, but yards squared is not the same thing as yard, right? And furthermore, miles squared is what I'm looking for, not miles. So to fix this, I'm simply going to square all of this. That way I get yards squared, and I'll square all of this. That way I get miles squared. The miles aren't such a big deal because 1 squared is still 1, but 1760 squared is going to be a lot different than 1760. So we just go ahead and square that sucker. Now it says 3.83, which is choice B, and our actual answer. And yes, in case you're wondering, this kind of trickery does show up not just with squared things, but also cubed things. So be on the lookout for that as well. Now, importantly, I want you to not be a nincompoop. Instead, you should click the link in the description, get your free access to all of those practice questions, and apply what you just learned so you don't forget it.